Nestled in eastern California lies Long Valley Caldera, a colossal volcanic crater near Mammoth Mountain, stretching 20 miles east to west and 11 miles north to south. This ancient caldera formed some 760,000 years ago. From a cataclysmic eruption, its depths plunged to 3,000 feet, while its floor sits high at 6,500 to 8,500 feet above sea level. This geological giant holds a volatile secret, a dormant volcano that scientists warn is showing signs of awakening. In today's discussion, we will explore the potential risks posed by this restless giant and also take a look at Mount Santa. Another notable volcanic feature in California, the geological type of Long Valley is a caldera, which is a large compression formed after a volcano erupts and collapses in early winter. The caldera is covered in snow, creating a picturesque landscape. The caldera's formation and the subsequent volcanic activity have shaped the region's geology and geography today. The Long Valley caldera is a significant geological feature that attracts scientists and tourists alike. Its history and structure offer insights into the Earth's volcanic activity and the forces that shape our planet near the center of the caldera. A magmatic uplift has created a resurgent dome. The southeastern slope of the caldera, which extends towards Bishop, California, is filled with the Bishop T. This tuff is solidified ash from the eruption that formed the caldera. The Bishop tuff is very thick in the caldera floor, about 1,500 m. The Owens River Gorge, which was formed during the Pine Era, cuts through this tuff. This gorge was created when the caldera filled with water and overflowed its rim. The rim of the caldera is made of pre-existing rock and rises about 3,000 feet above the caldera floor. However, the eastern rim is lower, only about 500 feet high. To the west of the structural rim of the caldera lies Mammoth Mountain, which is a lava dome complex. This complex consists of about 12 overlapping domes of Wright and Datey. These domes were formed during a series of eruptions that occurred from 110,000 to 57,000 years ago, resulting in a volcano that reaches an elevation of 11,590 feet. The monoino craters are a volcanic chain that stretches 25 miles along a narrow fissure system. This system runs from Mammoth Mountain to the north shore of Mono Lake. These craters erupted between 40,000 to 600 years ago from a magma source different from that of the Long Valley caldera. The caldera also has an extensive hydrothermal system at the base of the resurgent dome. Casa Diablo Hot Springs hosts a geothermal power plant. Hot Creek, which cuts into part of the resurgent dome, passes through several hot springs. The warm waters of Hot Creek support many trout and are used by the Hot Creek Fish Hatchery. However, swimming in Hot Creek has been prohibited since 2006 due to increased geothermal activity. The area around the caldera has several other hot springs, some of which are accessible to bathers. The Long Valley caldera's unique geological and hydrothermal features make it an area of significant scientific interest. Its formation, ongoing volcanic activity, and hydrothermal systems provide valuable insights into the Earth's processes. Today, the caldera attracts scientists and tourists both eager to explore and understand this remarkable geological feature. The geology of Long Valley caldera is complex and has puzzled scientists for years. Unlike other volcanic regions, Long Valley is not located above a hot spot like those in Hawaii, nor is it due to subduction, which is common in the Cascades. This makes understanding its origins more challenging and an ongoing area of research. The volcanic history of Long Valley started millions of years ago when magma began to gather several miles beneath the surface. Volcanic activity became concentrated in the area where Long Valley caldera is now located, between 3.1 to 2.5 million years ago. During this period, eruptions of Rodi began, followed by eruptions of Hyaroli from 2.1 to 0.8 million years ago. Over time, a cluster of mostly rhyolic volcanoes formed in the area, covering about 1,500 miles or 3,900 kilometers with lava. Most of these volcanoes were destroyed by a massive eruption 760,000 years ago, as we talked earlier, which had a volcanic explosivity index, or 7 of S. This eruption released 600 cubic kilm of material from vents located just inside the caldera's margin. For comparison, the 1980 eruption of Mount St. Helens, which had a 7 of 5, released only 1.2 cubic kilometers of material, about half of the material from the Long Valley eruption, was ejected in pyroclastic flows. These flows were extremely hot, around 1500 degrees or 820 degrees Celsius, and consisted of noxious gas PMUs and volcanic ash. They covered the surrounding area to a depth of hundreds of feet. One lobe of this material moved south into Owens's Valley, reaching past what is now Big Pine, California. Another lobe moved west over the Sierra Nevada crest into the San Juan River drainage. The rest of the pyroclastic material, along with 300 cubic kilm of other matter, was blown as far as 25 miles into the atmosphere wind, then carried this ash as far as eastern Nebraska and Kansas. The eruption initially created a caldera that was 2 to 3 kilm deep. However, much of the material ejected during the eruption fell back into the caldera, filling it about 23rd full. Today, the caldera is a prominent geological feature that provides scientists with valuable insights into volcanic processes and the Earth's geological history. It remains a subject of study as researchers continue to explore the causes and effects of such massive volcanic events. The Long Valley caldera has experienced several significant eruptions after its formation. Eruptions from the Long Valley magma chamber were mostly contained within the caldera between 700,000 to 600,000 years ago. Relatively hot rite erupted as the caldera floor uplifted to form what is now known as the resurgent dome. These eruptions were followed by cooler crystal, rich roly extrusions occurring roughly every 200,000 years. These took place around 500,000, 300,000, and 100,000 years ago, forming in a clockwise pattern around the resurgent dome over the past 650,000 years. Volcanic activity in the Long Valley caldera has decreased. The lava extruded became more crystalline over time. These patterns indicate that the magma reservoir beneath the caldera has largely crystallized because of this. Scientists believe that large-scale eruptions are unlikely to occur in the future. Long Valley's volcano is unique because it has produced both basaltic and CICC lava in the same area. Water from the Owens River once filled the caldera, creating a lake about 600,000 years ago. This lake reached a depth of 300 meters and had a surface elevation near 7,500 feet. The lake eventually drained after it overflowed. The southern rim of the caldera eroded the sill and formed the Owens River Gorge. Today, a dam in the gorge has created Lake Crowley, partially restoring the original lake since the major eruption. Many hot springs have appeared in the area, and the resurgent dome has continued to uplift during the last ice age. Glaciers filled the canyon leading to Long Valley, but the valley floor itself remained ice-free. Long Valley showcases excellent examples of terminal moraines, which are found at Laurel Creek, Convict Creek, and McGee Creek. These features offer a glimpse into the glacial history of the region and add to the geological diversity of the Long Valley caldera. In May 1980, a series of strong earthquakes hit the southern edge of the Long Valley caldera. These included 4 earthquakes that measured 6 on the ROR scale. This activity caused a 10-inch uplift in the caldera floor, which signaled the beginning of a period of unrest that continues to this day. The ongoing unrest includes repeated earthquake swarms and further uplift of the central part of the caldera. Changes in the thermal springs and gas emissions also accompany this activity. Following the 1980 earthquake, a new secondary access road was constructed as a potential escape route for the town of Mammoth Lakes, initially proposed as the Mammoth Escape Route. It was later renamed the Mammoth Scenic Loop after local businesses and landowners expressed concerns in 1982. The United States Geological Survey, or USGS, began a detailed monitoring and study program. Under the Volcano Hazards Program, the aim is to provide accurate information to residents and local authorities about the potential hazards posed by the ongoing unrest. The program also seeks to give timely warnings of any impending volcanic eruptions. Most volcanic eruptions are preceded by specific geophysical and geochemical changes. These include increased seismic activity, ground deformation, and changes in the nature and rate of gas emissions. The Long Valley caldera also hosts an active hydrothermal system. This system includes hot spring steam vents, known as ferrules and mineral deposits. Hot springs are mainly found in the eastern half of the caldera, where the land surface is lower. Ferrules are mostly located in the western half, where elevations are higher. The Resurgent Dome, Little Hot Creek Springs, Hot Creek Gorge, and other areas in the south and east moats of the caldera have notable mineral deposits resulting from thermal activity. The USGS's monitoring efforts are crucial for understanding the ongoing unrest in the Long Valley caldera. The collected data helps scientists track changes in the volcanic system and provides early warning signs of potential eruptions. This information is vital for the safety and preparedness of the local population and authorities, helping them respond effectively to any future volcanic events. Hot springs in the Long Valley caldera discharge, mainly in Hot Creek Gorge, along Little Hot Creek, and in the Alcal Lakes area. The largest springs are in Hot Creek Gorge, where about 250 liters per second of thermal water discharge. This accounts for roughly 80% of the total thermal water discharge in the caldera. In contrast, springs at the Hot Creek Fish Hatchery contain a small portion, around 2 to 5% of thermal water. This raises the water temperature by about 5 degrees Celsius above the background. The use of this warm spring water at the hatchery has increased. Fish production trout grow faster in the warm water compared to the cooler ambient stream temperatures in Long Valley. Now, before we continue, just make sure to give this video a like and also subscribe to the channel for more such videos in hydrothermal systems. Groundwater circulation is driven by a mix of topography and heat sources in Long Valley caldera. The system is recharged mainly from snowmelt in the highlands around the western and southern rims. Water from snowmelt and rainfall seeps to depths of a few kilometers, where it is heated to at least 220 degrees Celsius by hot rock near young geological intrusions. This heated water, being less dense, rises along steeply inclined fractures in the west moat to depths of 1 to 2 kilometers. The hydrothermal fluid then flows laterally, moving down the hydraulic gradient from the west to the southeast around the Resurgent Dome, and then eastward to discharge points along Hot Creek and near Crowley Lake Reservoir. Temperatures in the volcanic field decrease from 220 degrees near the Eno craters to 50 degrees near Crowley Lake due to a combination of heat loss and mixing with cold water. Hot Creek has been a popular swimming spot for decades. Since the late 1960s, over a dozen people have died in Hot Creek. Most deaths occurred when people ignored warning signs and used the hydrothermal pools as hot tubs. These pools can have dangerous temperature fluctuations with eruptions of superheated water. Recent geothermal instability led to the temporary closure of Hot Creek. For swimming, officials are uncertain when or if it will reopen for swimming. Hydrothermal activity has also transformed many rocks in the caldera, turning them into travertine and clay at the Huntley Clay Mine. White chalky clay, known as kaolinite, is mined. Kyanite is exposed on the Resurgent Dome, appearing as a brilliant white band. This geological feature adds to the unique and diverse landscape of the Long Valley caldera tourism. In the Long Valley caldera is a major draw due to its diverse outdoor activities. The Mammoth Mountain ski area is the largest attraction in the caldera. It offers skiing and snowboarding in winter and mountain biking. In summer, the Hot Creek area, once popular for swimming, was closed to swimmers in 2006 due to increased geothermal activity, making it unsafe. Hiking and off-road vehicle driving are popular activities throughout the caldera. The Sherwin Range, located immediately south of the caldera, has beautiful glacial valleys, perfect for hiking. Hikers can visit several lakes in these valleys, including Valentine Lake, Convict Lake, Lake Dorothy, and Laurel Lake's Crowley Lake. At the southern end of the caldera is well known for its excellent fishing opportunities. Visitors can find hotel accommodations in the nearby town of Mammoth Lakes, California. There are also many campgrounds throughout the caldera and in the mountains near its edge. These campgrounds provide a more rustic and nature-immersive experience for visitors who enjoy camping, despite its beauty and recreational opportunities. The area has had its share of tragedies. In April 2006, members of the Mammoth Mountain Ski Area Ski Patrol died while on duty. They suffocate from carbon dioxide when they fall into a fummer roll on the slopes of the mountain. This incident occurred while they were attempting to fence off the fumarole to protect others from falling in this tragic event, highlights the potential dangers in geothermal areas and the importance of safety measures. The combination of recreational activities, natural beauty, and the presence of geothermal features makes Long Valley Caldera a fascinating place for visitors. However, it also requires awareness and caution due to its geothermal activity. Now let's talk about the biggest volcano in California, Mount Shasta. Mount Shasta, located in Sisu County, California, stands tall at 14,179 feet as the second highest peak in the Cascade Range and the fifth highest in California. It is renowned for its volcanic origins, being the most voluminous stratovolcano in the Cascade Volcanic Arc, with an estimated volume of 85 cubic miles. The mountain part of the Shasta Trinity National Forest dominates the landscape, with its distinctive profile and is characterized by its 4 overlapping dormant volcanic cones. The name Shasta has uncertain origins, possibly derived from local Native American languages, or misunderstood by early European settlers. Mount Shasta is often accompanied by its satellite cone Shastina, which at 12,330 feet would rank as a significant peak on its own. In the Cascade Range, the mountain's steep rise of nearly 10,000 feet above its surroundings allows it to be visible from as far as 140 meters to the south. On clear days, geologically, Mount Shasta is composed of multiple volcanic cones shaping its complex topography, while its surface shows minimal glacial erosion, except on its southern side, where the prominent Sargent's Ridge and Avalanche Gulch are found. The mountain hosts 7 named glaciers, the largest among them. Whitney and Hotlam glaciers descend from the summit cone, with the Hotlam Glacier being the most voluminous in California. Historically, Mount Shasta has been significant to various Native American tribes, including the Shasta Modoc and Karuk, who have inhabited the region for millennia. The area saw the first Euro-American settlements during the California Gold Rush of the 1850s, with Mount Shasta becoming a prominent landmark along the Sisu Trail, a vital trade route connecting California's Central Valley with the Pacific Northwest. The first recorded ascent of Mount Shasta was achieved in 1854 by Ed Pierce, marking a milestone in its exploration. Since then, the mountain has attracted adventurers, poets, and authors, becoming a subject of admiration and inspiration due to its majestic beauty and cultural significance. The last known eruption of Mount Shasta occurred around 1250 AD, and despite its status as a potentially active volcano, it remains a cherished natural landmark and a haven for outdoor enthusiasts and researchers alike. It became a subject of scientific and literary interest by the 1860s and 1870s, with notable figures like John Muir, Josiah Whitney, Clarence King, and John Wesley Powell exploring its terrain in 1877. John M.'s harrowing experience surviving a blizzard near the summit captured public imagination, inspiring literary works like Kim Stanley Robinson's Muir on Shasta. The completion of the Central Pacific Railroad in 1887 along the historic Sisu Trail significantly boosted tourism, lumbering, and population growth around Mount Shasta. Early resorts such as Shasta Springs and Upper Soda Springs catered to adventurous tourists and mountaineers seeking to explore the mountain's natural beauty. In the early 20th century, the Pacific Highway, following the route of the Sisu Trail, further facilitated access to Mount Shasta. Increasing its popularity today, Interstate 5 serves as a modern version of the historic trail, bringing thousands of visitors annually to the mountain. A noteworthy meteorological event occurred from February 13, 1959, when the Mount Shasta Ski Bowl received a record-breaking 15.75 feet of snowfall during a single storm, highlighting the mountain's extreme weather conditions in recognition of its natural significance. Mount Shasta was designated a National Natural Landmark in December 1976. The mountain's cultural importance extends beyond its geological features, with legends from Native American tribes like the Sialth attributing spiritual significance to Mount Shasta as the dwelling place of powerful spirits. The area continues to attract a diverse range of spiritual seekers, from practitioners of Native American rituals to followers of various faiths drawn to Mount Shasta's Unique blend of natural beauty and spiritual mystique, around 593,000 years ago, the earliest eruptions formed its ancestral stratovolcano, building up to an unknown height until a massive collapse occurred between 300,000 and 360,000 years ago. Now, whatever your thoughts are, just write them down in the comments section below, and don't forget to subscribe to the channel for more informative content. Until then, keep exploring.